ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆಲ್ಲ ಆದರದ ಸ್ವಾಗತ. ನಾನು ನವೀನ್ ಕುಮಾರ್, ಸರ್ಕಾರಿ ಪದವಿ ಪೂರ್ವ ಕಾಲೇಜ್ ಹೆಬ್ರಿ ಇಲ್ಲಿ ಭೌತಶಾಸ್ತ್ರ ಉಪನ್ಯಾಸಕನಾಗಿ ಸೇವೆಯಲ್ಲಿದ್ದೇನೆ. ನನ್ನ ಇವತ್ತಿನ ಟಾಪಿಕ್ ಆಸಿಲೇಷನ್ ವೇವ್ಸ್ ಆ್ಯಂಡ್ ಸೌಂಡ್ಸ್. ನಾನು ಡೈರೆಕ್ಟಾಗಿ ಕ್ವಶನ್ ಪಾರ್ಟಿಗೆ ಹೋಗ್ತಾ ಇದ್ದೇನೆ. The angle between the instantaneous velocity and the acceleration of a particle executing simple harmonic motion is. ಇಲ್ಲಿ simple harmonic motion ಗೆ example for an oscillation of a mass suspended from the spring. When the mass oscillates about the mean position, if I consider this one is the mean position, acceleration is always directed towards the mean position. Acceleration direction is always towards the mean position, but velocity is maximum at mean position and it is zero at extreme position. When the body oscillates from extreme to mean position, both acceleration and velocity both are in the same direction. But when the body oscillates from mean to extreme position, the velocity direction, it is opposite to the acceleration direction. ಇಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಯಾವಾಗ ಬಾಡಿ ಮೀನ್ ಪೊಸಿಷನ್ ಕಡೆ ಚಲಿಸುತ್ತೆ ಆವಾಗ ಆಕ್ಸಿಲರೇಷನ್ ಮತ್ತು ವೆಲಾಸಿಟಿ ಒಂದೇ ದಿಕ್ಕಿನಲ್ಲಿರುತ್ತೆ. ದ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದೆಮ್ ಈಸ್ ಝೀರೋ. When the body oscillates from extreme to mean to extreme, velocity direction ಮತ್ತು acceleration opposite ದಿಕ್ಕಲ್ಲಿರುತ್ತೆ. Angle between these two vector is pi. Therefore, the correct option is 0 or pi. Move to the next question. A hollow ball is filled with water and then is used as the bob of the simple pendulum. If the water drains out of a small hole in the bottom, then how will it affect the time period? Okay, see there. In the simple pendulum, it consists of a long thread. One end is tied to the fixed end, other end to the bob. Here, sphere, it is completely filled with water. Now, we knew that time period of oscillation of a simple pendulum expression t equal to 2 pi square root of L by G. Here time period T directly proportional to the root of L. L is the length of the pendulum. It is measured from the fixed end up to the center of gravity of the bob. Now here bob, there is a small hole. When this bob is completely filled with water, the length L, it is measured from fixed end to up to C. Center of gravity is at the center of the sphere. As the water comes out from the sphere, the center of gravity position changes. The center of gravity position, it goes down, then length increases. Length increases. ಅರ್ಥಾಯ್ತಾ ಸ್ಟೂಡೆಂಟ್ಸ್? ಇಲ್ಲಿ ವಾಟರ್ ಸ್ಪಿಯರಿಂದ ಹೊರಬಂದಾಗೆ ಸೆಂಟರ್ ಆಫ್ ಗ್ರಾವಿಟಿ ಪೊಸಿಷನ್ ಕೆಳಗೆ ಹೋಗುತ್ತೆ. ಕೆಳಗೆ ಹೋದಾಗೆ ಈ ಲೆಂತ್ ಎಲ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಟೈಮ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ ಎಲ್. ಆಗ ಟೈಮ್ ಪೀರಿಯಡ್ ಇನ್ಕ್ರೀಸಸ್. ಈಗ ಅರ್ಧದಷ್ಟು ವಾಟರ್ ಖಾಲಿ ಆಗುವವರೆಗೆ ಸೆಂಟರ್ ಆಫ್ ಗ್ರಾವಿಟಿ ಪೊಸಿಷನ್ ಗೋಸ್ ಡೌನ್. ಆನಂತರ ಸೆಂಟರ್ ಆಫ್ ಗ್ರಾವಿಟಿ ಪೊಸಿಷನ್ ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ, ಮೇಲಕ್ಕೆ ಹೋಗುತ್ತೆ. ಆಗ ಎಲ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, T also decreases. When the whole of the water comes out from the sphere, center of gravity ಮೊದಲಿದ್ದ ಪೊಸಿಷನ್ಗೆ ಬರುತ್ತೆ. ಆಗ ಲೆಂತ್ ಎಲ್ ಆಗುತ್ತೆ, ಟೈಮ್ ಆಫ್ ಪೀರಿಯಡ್ ಆಫ್ ಪೆಂಡುಲಮ್ ಎಲ್ ಆಗುತ್ತೆ. The correct answer, time of period first increases and then it will decrease to ultimate acquire the initial value. Move to the next question. Okay, a pendulum is suspended from the ceiling of a compartment of a train. When the train is stationary, the time period of the pendulum is T. If the train accelerates, how will the time period of a pendulum change? Okay, time period, already I told T expression T equal to 2 pi square root of L by G. G is the acceleration due to gravity. The pendulum here, when the train is stationary, acceleration due to gravity G is there. When it is accelerate, here to accelerate, one is G acting vertically down, A is the acceleration of the train. Here time of rate, it comes under two acceleration which are mutually perpendicular to each other. Then the resultant of these two vectors A and G, if I consider resultant acceleration AR equal to, already you knew that according to law of parallelogram of two vectors, the resultant vector is given by AR equal to square root of A square plus G square plus 2AG cos theta. Here theta is 90, cos 90 equal to 0, then resultant acceleration AR equal to G square plus A square. There is a resultant acceleration is square root of G square plus A square. T is inversely proportional to acceleration due to gravity. Then T equal to 2 pi square root of L divided by G square plus A square. Then this denominator is increases, then time period it is decreases. There is a correct option. Or will the time period of the pendulum changes? Time period is, it is decreases. It will decrease. Okay, next question. Move to the next question. A particle executing SHM, its instantaneous acceleration is given by equation A equal to minus px, where p is the constant and x is the displacement from the mean position. The angular frequency of the particle is given by. Now in simple harmonic motion, already we knew that expression for acceleration of the oscillating body A equal to minus omega square x. X is the displacement. Now here given equation A equal to minus px, by comparing this to expression here omega square place, what is there? P is there, or omega, it is equal to square root of P. Now in the given option, the omega is the angular frequency of the particle, it is equal to root P. Okay, move to the next question. A body executing SHM as amplitude of 4 centimeter, what is the distance at which the body has equal value of both kinetic energy and potential energy? Here you have to find the value, position. Consider y is the position at which the value of kinetic energy, it is equal to potential energy. Now kinetic energy is general expression of mv square, but v in terms of omega, v equal to omega into square root of a square minus y square. Then we can write here of m v square. Now squaring on both sides, we can get v square equal to omega square of a square minus y square. Your potential energy expression of m omega square y square. Now equating of m omega square y square. Here of m omega square get cancelled. Remaining term a square minus y square equal to y square, or a square equal to y square plus y square, that is 2 times y square. Taking square root on both the sides, we can get a equal to root 2 times y, or y equal to amplitude a divided by root 2. Amplitude is given 4 centimeter, that is 4 divided by root 2. This option is not there. 4 you can write 2 into 2 divided by root 2. Now 2 we can write in the form root 2 into root 2, 1 root 2 get cancelled, remaining is 2 root 2. Okay, correct option is 2 root 2 centimeter. Move to the next question. A particle executing simple harmonic motion has an amplitude of 6 centimeter. Its acceleration at a distance from the mean position 2 centimeter is 8 centimeter square, the maximum speed of the particle. Now we knew that velocity expression of speed omega square root of a square minus y square. Velocity is maximum at the mean position. For the mean position, displacement y equal to 0 or v maximum we can get equal to omega square root of a square is a. But here acceleration is given. Acceleration expression for the oscillating body a equal to minus omega square y. Now here acceleration at the mean position 2 centimeter is 8 centimeter square. Acceleration is 8 centimeter per second square minus omega square y is given there 2 centimeter into 2, or you can consider only the magnitude, then plus or omega square equal to 2 1s are 2 4s are. Omega square is 4, omega is root of 4 is 2. Then we can get V maximum equal to omega is 2 into amplitude, it is given, amplitude is 6, 2 into 6 equal to 12 unit, that is centimeter per second. Correct option is 12 centimeter per second. Move to the next question. Seventh one. A body falling freely on a planet covers 8 meter in 2 seconds. The time period of 1 meter long simple pendulum on this planet will be. Now here given a body is falling freely under gravity. For the freely falling, its initial velocity is equal to 0. It covers the distance 8 meter in 2 seconds. That is x is 8 meter, time is 2 seconds. Now using the equation for freely falling body, equation of motion, we get x equal to half gt square. Here v naught equal to 0. Or x is 8 into half, g is unknown, t is 2 is given, 2 square, 2 8s are 16, divided by 4, it is equal to g. G, that is g equal to 16 by 4, that is 4 meter per second square. Now to find out here time period of the 1 meter long, here g is 4, time period formula t equal to 2 pi whole square root of L by g. Now substitute for L is given 1 meter long, length 1, divided by 4, here we got 4, g is 4. Then simplifying this one, we can get 2 pi square root of 4, that is 2, 2 get cancelled, pi value is 22 by 7, that is equal to 3.14 second. That is the correct option is here 3.14 second. Okay, move to the next question. Eighth one, a mass m attached to the spring oscillates with a period of 3 seconds. If the mass is increased by 1 kg, the period increases by 1 second. The initial mass m is. Here mass m attached to the period of 3 seconds. Now in case of oscillation of a mass suspended from the spring, the expression for time period of the mass. Now in your class, on the theory, it is already derivation is there, already you studied. T equal to expression T equal to 2 pi square root of m divided by k. Now T and mass relation here, T directly proportional to square root of m. Now first mass m attached to time period is here 3 seconds, then T is 3 seconds, mass is m, 3 directly proportional to root of m. Next mass is increased by 1 kg, mass becomes m plus 1. You have to find out the initial mass, then time period is increases by 1 second. Initially it is given 3, 3 plus 1, time period 3 plus 1, that becomes 4. It's 4 directly proportional to m plus 1. Now dividing these two expressions, we can get root of m plus 1 divided by root of m equal to 4 divided by 3. Now squaring on both sides, we can get m plus 1 divided by m equal to 4 square is 16, 3 square is 9. Then cross multiplied, we can get m plus 1 times 9 equal to 16m. Simplify this one, 9m plus 9 equal to 16m. That implies 16m minus 7m, that 16m minus 9m, 7m. 7m, it is equal to 9, or m equal to 9 divided by 7 kg. Now correct option is, this is a B, it is the given 9 by 7 kg. Okay, move to the next problem, that is the 9th one. Two springs fixed at one end are stretched by a 5 cm, 10 cm respectively, and masses 0.5 kg, 1 kg are suspended at the lower ends. When displaced slightly from their mean position and released, they will oscillate with the time periods in the ratio. Now here time period, already we knew that time period T is directly proportional to mass m. Mass, if I consider first one mass m1 is 0.5, m2 is 2 kg, then ratio to find out T1 directly proportional to square root of 0.5 time period to T2 for the second mass, that is second one is mass m2 is given 1 kg. You have to find the ratio T1 divided by T2, that is equal to square root of 0.5 divided by 1, that is T1 divided by T2. You can write in the form 0.5, that is the half. You can write half, that is 1 by 2, that is equal to, it is in the ratio T1 is to T2, it is in the ratio root 1 into root 2, root 2 1 is 1, 1 is to 2. Correct option is 1 is to 2. Okay. Move to the next question, 10th one. Here a body of mass 5 kg is executing SHM with amplitude of 10 cm. Its maximum velocity is 10 cm per second. Its velocity will be 50 cm per second at a displacement from the mean position equal to. Okay, here see that your body of mass is given 5 kg, amplitude is given 4 centimeter, mass 5 gram is given, 5 gram. It is executing in amplitude, A given 10 centimeter. Its maximum velocity, now this one is the maximum velocity, 100 centimeter per second. Its velocity will be 50 centimeter at a displacement from the mean position is. Now velocity expression V equal to omega square root of a square minus y square. You have to find out the which one. Velocity will be 50 at a displacement. Displacement y is unknown. You have to find out displacement. Now maximum it is given. P maximum it is given 100 centimeter per second. Okay. V maximum expression for maximum velocity here y equal to 0, or V maximum is expression omega a. Now from this expression, if we substitute for V maximum 100, omega a is given 10 centimeter, 10 into 10, 0 get cancelled, omega you can get 10. Here omega is 10 unit. Now substitute in this expression. Here V is given 50. 50 equal to omega, there you got 10 square root of a square. A is 10 minus y square. Here 0 get cancelled. 5 equal to square root of 10 minus y square. Now root is there. Squaring on both sides, you can get 5 square is 25. Here square and root get cancelled. 10 minus y square. Okay, once again check it here. V maximum it is given. Maximum is 100, omega a, or omega is, you can get, a is 10, no? Omega is 10. Okay, you have to find out velocity is given 50, 50, 10. There is amplitude is given 10. Your square is there, 10 square. 10 square is 100, 100. Or y square you can write in the form y square equal to 100 minus 25. 100 minus 25, that is 75. Or y equal to square root of 75. Here square root of 75 option is not there. Okay, simplify this one. 75 you can write in the form 25 into 3. Now 25, square root of 25 is 5, 5 root 3. Okay, correct option is 5 root 3 centimeter. Okay, your correct option is 5 root 3. Okay, move to the next question. 11th one. The period of a particle in SHM is 8 seconds at t equal to 0 at the mean position. The ratio of the distance travelled by it in the first and the second is. Now, we know that equation, general equation for simple harmonic motion, y equal to a sine omega t. But here time in terms of period, omega, you can write y equal to a sine 2 pi divided by capital T into t. If I consider y1 is the distance travelled in a time t1 per second, t1 equal to 1 second, then we can get y1 equal to a sine. Now their time period is given, time period of it is given 8 seconds. Now substitute t place 8 into t1 there, t1 is 1 second. Or you can write y1 equal to a sine, that is 2 pi by 8, that is pi by 4, sine pi by 4, that is sine 45 degree. The value of sine 45 degree is 1 by root 2, that is a divided by root 2. y1 equal to a divided by root 2. Next you have to calculate distance travelled in the total time 2 seconds. Then apply the same equation, y1 equal to, you can get a sine 2 pi time period is t given, but time here 2 seconds. Now simplifying this one, a sine, that is 2 pi by 8, that is sine 45, that is 1 by root 2, that is 2 divided by 2 into 2, here 2 into 2, 2 ones are, 2 fours are, you can get 360 degree divided by sine 90, that is 1. That is y2, you can get a. Understood, no? Now y1 is distance travelled in 1 second, but y2 is the total distance travelled in 2 seconds. Only there substitute for 2. By simplifying this one, we can get y2 equal to a. But here you have to find the ratio of distance travelled in the first and the second. Second is, it is the distance travelled in the second is here y2, total distance travelled in 2 seconds minus distance travelled in 1 second. You have to subtract y1 plus from y2. y2 here we got here, y1 is a by 2, a by root 2. Okay, here a is common, we can take outside, we can write in the form 1 minus 1 by root 2. Next, you have to find the ratio y1 divided by y2. Here y1, that is a by root 2 whole divided by a of 1 minus 1 divided by root 2. Here a get cancelled, that is 1, root 2 comes to denominator. Here root 2, take the common denominator root 2 minus 1 whole divided by root 2. Root 2 get cancelled, you got 1 divided by root 2 minus 1. Now that is in the ratio 1 is to root 2 minus 1. Correct option is D, that is 1 is to root 2 minus 1. Okay, move to the next question, 12th one. The mass and diameter of the planet are twice those of Earth. The time period of simple pendulum on this planet, if it is seconds pendulum on Earth is, okay, mass of the planet is twice that of Earth. If I consider mass of planet, it is twice that of Earth, and diameter is given twice. Similarly there, radius of the planet, it is the twice that of the Earth. R is the radius of the Earth. Now in the gravitation chapter you studied, there is a relation between small g and capital G, where small g equal to g me divided by re square. Okay, where g is acceleration due to gravity on the surface of the Earth. For the planet, gp equal to g mp divided by rp square. Now time period and which one, acceleration due to gravity relation, we knew that t equal to 2 pi whole square root of L by g, or t is directly proportional to 1 divided by square root of g. Okay, now here find the ratio gp divided by g, dividing g get cancelled, that is mp divided by rp square into re square divided by me. Then substitute for mp, that is 2 times mass of the Earth. Here rp is 2 times the radius of the Earth, 2 re whole square into re square divided by me. Me get cancelled, re square get cancelled, you can get, that is 2 divided by 4, here 2 square is there, that is 1 by 2. That is gp is acceleration due to gravity on the surface of the planet, that is half of g. Now t inversely proportional to root of g, or Tp divided by t, you can get 1 by root of Gp into 1 by Tp by t equal to 1 by square root of Gp into G divided by 1. That is equal to, now here Gp is G by 2, substitute for Gp G by 2, here G by 2 whole square root of G get cancelled, or Tp divided by T equal to root 2. But they are given the time period of simple on the plate. If it's seconds pendulum on earth, for the seconds pendulum, time required for one full oscillation is 2 seconds. 2 seconds, their Tp we can get, their T is 2 seconds, Tp equal to 2 root 2 times 2 root 2 square root of 2 seconds. D, that is time period for the seconds pendulum on that planet is 2 times root 2 second. Okay, move to the next problem, 13th one. A particle is executing simple harmonic motion. It is given by x equal to 5 sine of 4t minus pi by 6, the velocity of the particle when the displacement is 3 units. Now we know that for a simple harmonic motion, we have to write the standard equation for this given equation. Standard equation here, x equal to a sine omega t, okay, minus, can consider pi, where pi is pi by 6. But you have to find out here velocity of the particle when displacement is 3. Velocity expression v equal to omega square root of a square minus y square. Now comparing these two equation, here 4t is there, here omega t, comparing omega we can get 4, then amplitude place here a, amplitude, okay, we can get 5, amplitude 5. Now displacement is given y equal to 3 unit. By substituting these values in this expression, we can get omega is 4 a square, that is 25, minus 3 square is 9. V equal to 4. So 25 minus 9, we can get, there is 16, correct, no? 16. Square root of 16 is 4, that is 4 into 4, 4 into 4, that is 16 units. Correct option for this question is 16 units. Okay, move to the next question, that is the 14th one question. A pendulum clock is set to give correct time at the sea level. This clock is moved to a hill station at an altitude of 2500 meters above the sea level. In order to keep correct time on the hill station, the length of the pendulum. Now time period t expression, t equal to 2 pi square root of L by G. Now in the gravitation chapter, you studied about variation of G with height or altitude. Now G expression there, GH equal to G of 1 plus H divided by RE to the power minus 2. But here height is given 2500 meter. If we comparing height and radius of the earth, here height is very small, radius of the earth nearly 6400 kilometer. If height is very small compared to RE, then expression of acceleration due to gravity at a height h, gh equal to g of 1 minus 2h divided by RE. Now this one, okay, simple pendulum, it is placed 2000 feet above the sea level. Height increased means GH decreases, correct no? Here 2h by RE value increases, but 1 minus 2h by RE value decreases, GH decreases. As the height increases, G value decreases. Now the height time of period directly proportional to L by GH. Here GH decreases, but in order to keep correct time, now to keep the time period same, T, to keep time period same value to get the length of the pendulum. This decreases, then L, it must be decrease. You have to get the L by GH, this value constant. Understood no? ಅರ್ಥ ಆಯ್ತಾ ಇಲ್ಲಿ? ಹೈಟ್ ಜಾಸ್ತಿ ಆದಾಗೆ ಆಕ್ಸಲರೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅಲ್ಲಿ ಜಿ ಎಚ್ ಕಡಿಮೆ ಆದರೆ ನಾರ್ಮಲಿ ಟೈಮ್ ಆಫ್ ಪೀರಿಯಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಆದರೆ ಇಲ್ಲಿ ಈ ಕ್ವಶನಲ್ಲಿ ಟೈಮ್ ಆಫ್ ಪೀರಿಯಡನ್ನು ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಮೊದಲಿದ್ದಷ್ಟೇ ಇಟ್ಕೋಬೇಕಾದ್ರೆ ಲೆಂತನ್ನು ಕಡಿಮೆ ಮಾಡಲೇಬೇಕು. ಲೆಂತ್ ಆಫ್ ದ ಪೆಂಡುಲಮ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ರೆಡ್ಯೂಸ್. Therefore, correct option is length has to be reduced. Okay, move to the next question. 15th one. The length of a simple pendulum is increased by 44%. The percentage increases in its time period will be. Now, length is increased. Now, length and time period of pendulum relation. Time period T directly proportional to length of the simple pendulum. Length is increased means, if I consider initial length L, final L dash equal to L plus how many percent? 44% increase. It's the 44% of L, 44 divided by 100, that is 0.44 into L. Or L dash equal to, you can get 1.44 L. Now T directly proportional to root of L, T dash directly proportional to square root of L dash. Or dividing T dash by T, you can get a square root of L dash divided by square root of L. That implies T dash divided by T equal to square root of, now L dash here 1.44 L divided by square root of L. Square root of L get cancelled, or T dash equal to root 1.44 times T, that is root square root of 1.44 is, its value is 1.2T. You can write T plus 0.T. Now 1.2T, you can write 1T plus 0.2T. T is the initial tension. T is the initial tension, but increased is 0.2T. Or in terms of percentage, this one is 20% of T. Correct option is 20% of T. Understood now? If it is increases by 20% plus, if it is suppose it is decreases by 20% means you have to minus, correct? It decreases by 20% means we can get 0.8. 0.8 means 80% decreases. Now here it is increases plus 0.2. That is the answer is 20% increases. Okay, move to the next problem. 16th one. A vibrating tuning fork generates a wave equation is given by y equal to 0.1 sin pi of 0.1 x minus 2t, where x and y are in meter and t is in second. The distance travelled by the wave while the fork completes 30 vibration. For one vibration, distance travelled is for one vibration, distance traveled for one full wave, distance traveled is lambda. For 30 oscillation, distance traveled is 30 times lambda. You have to find out 30 times lambda. Now to find out lambda, there one equation is given, y equal to 0.1 sine pi of 0.1 x minus 2t. Now we knew the standard equation, y equal to a sine here kx minus omega t. The given equation you have to compare with the standard equation. Now here k place, here pi is outside the bracket, bring this one pi inside, we can get 0.1 pi x minus 20 pi t. Now comparing here, k place, we can get k equal to 0.1 times pi. Correct. Pi, it is the angular wave number. What is the expression for k? You knew that k is 2 pi divided by lambda. K is 2 pi divided by lambda, that is equal to 0.1 times pi, where pi get cancelled. We can get lambda equal to, lambda is 2 divided by 0.1. 2 divided by 0.1, its value is 20. That's 30 times lambda means here 30 into 20. 3 2s are 6, 20, that's answer is 16 meter. Now therefore right answer is 600 meter. Okay, move to the next problem, 17th one. The equation of a wave is represented by y equal to 10 to the power minus 4 sine of under t minus x by 10 in meter. Then the velocity of the wave will be. Now velocity, here velocity you have to find out. Equation is given. Your position displacement is not given. Here also you have to write the standard equation. You knew that y equal to a sine of omega t minus kx. Okay, by comparing these two equations, you have to find out frequency and wavelength. The relation between velocity, frequency and wavelength, v equal to nu times lambda. But here comparing omega plus 100 is there. Omega is 100. Angular frequency, that is in terms of frequency, 2 pi nu equal to 100, or nu equal to 100 divided by 2 pi. Nu equal to 100 divided by 2 pi, that is 50 divided by 2 ones are 250 is 50 by pi. Now k place here, comparing k, you can get x by 10, k equal to x divided by 10. Expression for k is 2 pi by lambda equal to, not x here, k x place now, x get cancelled, that is 1 by 10, or that implies lambda equal to 10s are 20 pi. Now substitute here nu and lambda. Nu is 50 by pi into lambda is 20 pi. Pi get cancelled. 20 into 50, that is 1000. The correct option is 1000 meter per second. Right answer is not this one, sorry, this one, 1000 meter per second. Okay, move to the next problem, 18th one. If two waves of the same frequency and same amplitude respectively on superposition produce a resultant disturbance of the same amplitude, the waves differ in phase by. Now we know that according to principle of superposition of waves, resultant displacement, it is the sum of the displacement of the individual waves. And also you knew that two vectors whose magnitude A and B, if they are represented by the two adjacent sides of the parallelogram, then the resultant of two vectors, or the square of the resultant, it is given by expression A square plus B square plus 2AB cos theta. Now here two have same frequency, same amplitude respective on resultant disturbance also same amplitude. Now amplitude is same, AB equal, it is equal to resultant. If we substitute R place A square equal to A square, B also is given same, A square plus, you substitute B place A into A square, that is cos theta. Now simplify, 1 A square get cancelled. Now plus A square bring it to left hand side, it becomes minus A square, that is equal to 2A square cos theta. A square get cancelled, cos theta here we get, it is equal to minus 1 by 2. Okay. Now cos theta is minus 1 by 2. Of which angle? For which angle of cos angle is minus of, that is for cos 120 degree. Now theta is 120 degree, but option is given in terms of radian, pi. Convert into pi radian, pi by 180, 0 get cancelled, 6 2s are, 6 3s are, correct option is 2 pi divided by 3 radian. Okay, here P is the right answer. Okay, move to the next problem. In a gas, two waves of length is given 1 meter and 1.01 meter superposed to produce 10 beats in 3 seconds. The velocity of the sound in this medium is, okay, two length, one is L1, L2 is given, beats, your beat frequency is 10 beats in 3 seconds, that is 10 divided by 3 hertz beats, the velocity of sound in this medium. Now here, if I consider here two sound waves of frequencies different, one is nu1, nu2, then beat frequency, it is the difference between nu1 and, this one nu2, difference between nu1 and nu2. Now nu, in terms of velocity, we knew that v equal to nu times lambda, or nu equal to velocity divided by lambda. Substitute nu v place 10 by 3, nu1 place, velocity remains same here, lambda 1, nu2 place v divided by lambda 2. Okay, 10 by 3, v is common, it's taken outside, inside the bracket. Lambda 1 is given, first one is 1 meter, minus lambda 2 is given 1.01. By simplify this one, we can get 10 by 3 equal to V inside the bracket. Common denominator is 1.01. Here 1.01 minus 1, that is 10 by 3 equal to V. 1.01 minus 1 is 0.01 divided by 1.01, that implies V equal to 10 into 1.01 divided by 3 into 0.01. Now here this one you can write, multiplying dividing by 100, this one you can write 101, this one is 1, that is 10 into 101, that is 1010 divided by 3. 3 how many times divides here? 3 ones are, 3 threes are 9, 1 is carry, 3 3 are 9, 2 carry, 2 6 are 18, next point 2066. Can get 336.66. Now nearest value, okay, now this one rounding off this number, you can get 337. Okay, correct option is 337 meter per second. Okay, 20th one. The mass of a string of 4 meter is 16 kg. If the tension in the string be 40 Newton, then what is the speed of sound waves in the string? Now, in the string, the speed is given by expression that is the square root of T tension applied on the string divided by mu. Mu is the linear mass density. Now here linear mass density formula, it is mass divided by length. Here mass given, mass 16 gram is given in terms of kg, 16 into 10 to the power minus 3. It convert into kg because this one tension Newton SI system force SI system given divided by length is 4 meter, or length also in SI system given. That is 16 by 4, that is 4 into 10 to the power minus 3. You substitute V, square root of T is 40 Newton whole divided by 4 into 10 to the power minus 3, that is equal to 4 1s are 4 10s are 10 into 10 to the power minus 3, it comes numerator, it becomes plus, that is square root of 10 to the power 4, that is, take this outside from the square root, we can get 10 square. 10 square is 100 meter per velocity, 100 meter per second. Correct option is 100 meter per second. Okay, move to the next question, that is the 21st. When the temperature of an ideal gas is increased by 600 Kelvin, the velocity of sound in the gas becomes root 3 times the initial velocity in T, the initial temperature of the gas. Now, according to Newton-Laplace corrected formula, Laplace corrected Newton's formula, expression V equal to square root of gamma P by rho. Now, rho is the density. Now, density in terms of mass, density is mass divided by volume. You can write gamma PV divided by M. Now for ideal gas equation, PV equal to RT. Here given temperature for ideal gas, you have to find out PV equal to RT. Now that this PV is RT, that means V directly proportional to square root of absolute scale of temperature or temperature in Kelvin scale. Here given, if the velocity of sound, it becomes root 3 times the initial velocity. Okay. Increased by, when the temperature is increased by, temperature is becomes T dash, T plus 600. Okay. V directly proportional root T, 3V given 3 times it is increases, no, root 3 times increases, root 3 times V, we can get temperature is increased by initial T plus 600. Now dividing these two expression, we can get root 3, we get cancelled, root 3 equal to square root of T divided T plus 600 divided by square root of T. Okay. Now squaring on both sides, we can get 3 equal to, squaring on both sides, 3 equal to T plus 600 divided by T. That is 3T equal to 600 plus T, or 2T equal to 600, T equal to 600 by 2, how many times divides 300. Now T got initial temperature is 300 Kelvin, but option is given in degree Celsius. You have to convert Kelvin into degree Celsius. You have to minus 300 minus 273. Then you can get 300 minus 273 is 27 degree Celsius. Understood, no? While converting degree Celsius into Kelvin, you have to add, no? Add 273. Here you have to convert Kelvin into degree Celsius. You have to subtract, so 273. Okay, move to the next problem. 22nd one, a man is standing between two parallel clips and fires a gun. If he hears the first and the second echoes after 1.5 second and 3.5 second respectively, the distance between the clips is, your velocity of sound is given 340 meter per second. Consider two clips. Okay, first one, second one. Your man standing in between. He fires the gun. If I consider x1 is the distance from the man to the first clip, x2 is the distance from the man to the second clips. Your total distance traveled by the bullet when it's fired from the gun, or the total distance traveled by the sound, it is given by total distance x1 from this place to first clip x1, then returns, comes back to first clip to the person, that is x1 plus x1. Now this side also same, the total distance traveled by the sound waves is x2 from the person to second clip and reflect and back to the person, again x2, that is total distance here also, x2 plus x2. You can write it as 2x2, total distance is, total distance 2x2 plus 2x1. But you have to find out the distance between these two clips is x1 plus x2 equal to how much? Now speed is formula total distance divided by time taken, total time. Here velocity of sound is given 340. Total distance 2 is common, you can take 2 outside, 2 of x2 plus x1 divided by total time here 1.5, it is given 1.5, 3.5, then total it becomes 1.5, 3.5 is 5, no, that is 340 is equal to 2 of x2 plus x1 divided by 5. So simplify this one, 2 ones are 2, 7s are 14, 0. Or x2 plus x1, it is equal to 5 into 70. 5 0, 5 7s are 35, 5 1s are 5, that is 850 meter is the correct option. Your total distance between the two clips is 850 meter. Okay, move to the next problem. A source of sound of frequency 600 Hz is placed inside the water. The speed of sound in water is 1500 meter per second and in air it is 300 meter per second. The frequency of sound recorded by an observer is standing in air. Now, when a waves in traveling from one medium to another medium, for an example air to water, now here velocity changes air to water, velocity decreases and wavelength also changes, but frequency remains same. Here frequency remains same, or nu equal to V by lambda. Frequency remains constant. Now source of frequency sound, it is in water it is given 600 Hz. Therefore in air also it remains same 600 Hz. Correct option is 600 Hz. Okay, move to the next problem. That is the 24th problem. The equation of a stationary wave along a stretched string is given by y equal to 5 sine of 5x by 3 cos 40 pi t, where x and y are in centimeter, t is in second, the separation between two adjacent nodes. Now, what is the condition for formation of stationary waves? Now, when two identical waves, they are superimposed of same amplitude, identical means they have same amplitude, same frequency, same speed, but they are traveling in opposite direction. Now standing wave is formed, one wave, and another wave, same identical but traveling in opposite directions. Now you have to find out the separation between two adjacent nodes. Now at this location, displacement, it's permanently remains at rest. It's the displacement is 0. Now node to node, distance between node to node, that is lambda by 2, half of the wavelength. You have to find out lambda by 2, node to node distance, this one, lambda by 2. Now equation is given. Here also you have to remember the which one, standard equation of stationary waves. Now standard equation for stationary waves, y equal to, that is 2a sine kx cos 40 pi t is the standard equation. Now compare here. You have to find out lambda, no? Lambda, k is here. Now k place here, k place what is there? Pi by 3. By comparing, you can get angular wave number k is pi divided by 3. Okay, expression in terms of wavelength, that is k is 2 pi by lambda, it is equal to pi divided by 3. Where pi get cancelled, lambda you can get 3 into 2, that is 6. Lambda is 6 centimeter. You are given XYR in centimeter. That is lambda by 2, node to node distance, that is the half of 6, that is 3. Correct option is 3 centimeter. Okay, move to the next problem. Two tunic forks are sounded together and produce 5 beats per second. The frequency of one of them is 250 Hz. The other is loaded with a little wax, and now they produce 7 beats per second. The frequency of the other tunic fork is. So beat frequency, general formula beat frequency, it is equal to nu1 difference nu2. But here nu1 is given. Nu1 is given how much? Nu1 is 250 Hz is given, and the nu2 is unknown. Nu2 is unknown, but beat frequency is given 5 bits. 5 bits. That is for nu2. You can say that nu2 equal to nu1 plus or minus nu b. Understood now? Okay. That is nu1 is 250. Nu2 is, it may be more than which one? 5 Hz. More than 250 or less by 5 Hz. From which one? 250 Hz. Then nu2, it is 250, nu1 is 250, nu2 is 250 plus 5, that's 255 Hz, or 250 minus 5, that is 245 Hz. Understood now? Here nu2 is 250 plus 5 or 250 minus 5. Then it is given the second tunic fork for that frequency nu2, it is loaded with a little wax. Little wax is loaded, and now they produce 7 beats per second. Now beat frequency is 7 beats per second. Okay. Now when it is loaded with little wax, that's frequency nu2, it is slightly decreases it here. Okay, this one is reduced. Suppose this one 255 ಕಡಿಮೆ ಆದರೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಎಷ್ಟಾಗುತ್ತೆ? 244 ಆದರೆ 4 ಆಗುತ್ತೆ, ಇದಕ್ಕಿಂತ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದೇ ನೀವು 245 ಕಡಿಮೆ ಮಾಡಿದರೆ ಈಗ 244 ಆದರೆ 6 ಬರುತ್ತೆ. ಅದೇ 247 ಆದರೆ 247 ಅದು 7 ಬರೋ ಚಾನ್ಸಸ್ ಇದೆ. ಅಂದರೆ ಈ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆದರೆ 245 ಆದರೆ ಮಾತ್ರ ಚಾನ್ಸಸ್ 7 ಬೀಟ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಲಿ ಚಾನ್ಸಸ್. ದೇರ್ ಫೋರ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ nu2 is 245 hertz. Okay, ಅಂದರೆ ಇಲ್ಲಿ beat frequency after loaded with wax nu b dash if it is greater than nu b, ಮೊದಲಿದ ಫ್ರೀಕ್ವೆನ್ಸಿಗಿಂತ ಜಾಸ್ತಿ ಬಂದರೆ ದಿಸ್ ಒನ್ nu b, then nu 2 ಎಂಬುದು nu 2 is less than nu 2 is less than nu 1. Nu 2 is less than nu 1. That is nu 2 equal to nu 1 minus this one beat frequency 5. If otherwise, if nu b dash it is got less than nu b, then you can get nu 2 is greater than nu 1. Okay, understood now? Your correct option is 245 hertz. Okay, 26 one. Velocity of sound in a gaseous medium is 330 meter per second if the pressure is increased by 4 times without change in temperature. The velocity of sound in the gas. Velocity of sound in a medium, it is given 330 meter per second if the pressure is increased by 4 times. Now same formula, Laplace corrected Newton's formula, V equal to square root of gamma p by rho, correct now. Rho in terms of mass and volume, m by v, or you can write gamma pv divided by m. Now according to Boyle's law, at constant temperature is not changed. When the temperature is kept constant, volume of a given mass of a gas is inversely proportional to pressure, or PV equal to constant. PV equal to constant. Here pressure is increased by 4 times without change in temperature. Temperature constant. If pressure is increased, then volume, it must be increased or decreased. It must be decreased. Now this product, it remains constant. If pressure is increased, then volume is decreased. Understood now? Pressure ಜಾಸ್ತಿ ಆದಾಗ ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದರ ಪಿ ವಿ ಎಂಬುದು ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟ್. ಅದೇ ಪ್ರೆಷರ್ ನೀವು ಕಡಿಮೆ ಮಾಡಿದಾಗ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಆದರೆ this product, it remains constant. Therefore velocity of sound, it is independent of pressure. V is independent of pressure. Understood now? If the pressure is increased by 4 without change, the velocity of sound in gas, it remains same. Velocity of sound is independent of pressure. Correct option is 330 meter per second. I hope you will understood this one. Okay, move to the next problem. 27th one. Two waves of wavelength 99 centimeter and 100 centimeter, both traveling with velocity of 396 meter per second, are made of interface. The number of beats produced by them per second is, also same formula, beat frequency nu b equal to nu 1 difference nu 2. Okay. Now here nu 1 in terms of velocity is given nu 1 equal to velocity v divided by lambda 1, that is v is 396, it is given. Wavelength is 99 centimeter, in terms of meter 0.99 meter. The nu 2 you can get velocity is 396, wavelength is 1, lambda 2 is given 100 centimeter in terms of meter 1. Now here nu b, beat frequency relation difference. Now comparing this one, nu 1 and nu 2, which one is greater? Nu 1 is greater than nu 2, no? Denominator here 0.99. 0.99 is less than 1. Therefore nu 1 is greater than nu 2. Understood now? ಇಲ್ಲಿ beat frequency ಅನ್ನು ಕಂಡುಹಿಡಿಯುವ ಫಾರ್ಮುಲಾ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ nu 1 nu 2. ಅಂದರೆ ದೊಡ್ಡ ವ್ಯಾಲ್ಯೂವಿಂದ ಸಣ್ಣ ವ್ಯಾಲ್ಯೂವನ್ನು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಇದೆರಡು ಎಕ್ಸ್ಪ್ರೆಷನಲ್ಲಿ ನೋಡಿದಾಗ ನ್ಯೂ1 ಅದು ಡಿನೋಮಿನೇಟರ್ 0.99 ಇತ್ತು, ನ್ಯೂ2 ಅದು 1 ಇದೆ. ಕಂಪೇರ್ ಮಾಡಿದರೆ ನ್ಯೂ1 ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇದೆ. ನ್ಯೂ1 ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ ನ್ಯೂ2. Alright, yeah, new B, you have to find out new B. New1 place 396 is, you can take outside. It is 1 divided by 0.99 minus 1 divided by 1. 396 into common denominator 0.99. Here 1 minus 0.99, that you can get 396 into 1 minus 0.99, that is 0.01 divided by 0.99. Here multiplying and dividing by 100. ಎಷ್ಟಾಗುತ್ತೆ 0.01 ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಹೋಗುತ್ತೆ, 1 ಇರುತ್ತೆ. 396. ಸಿಮಿಲರ್ಲಿ ದ ಡಿನೋಮಿನೇಟರಿಂದ 100 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದರೆ 99 ಬರುತ್ತೆ. ಆನ್ಸರ್ ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ ಡಿವೈಡ್ಸ್ 99? 99 4s are correct, no? 4s are divides. 4 9s are 36. Yes, right? That is answer is 4. Now correct option is number of bits produced them. Second is 4. Okay, move to the next problem, 28th one. 28th, a segment of wire vibrates with fundamental frequency of 450 Hz under a tension of 9 kg weight. Then tension at which the fundamental frequency of the same wire becomes. Now here fundamental frequency, the stretched vibration of a stretched wire, no? Now fundamental frequency general expression, it is given by nu equal to NV divided by 2L. Now fundamental mode means the given string which vibrates with the lowest frequency. For the lowest frequency, for the fundamental frequency n equal to 1, nu equal to V divided by 2L, or nu V in terms of which one here 9 kg tension, in terms of tension formula, nu equal to 1 divided by 2L square root of T divided by mu. Mu is the linear mass density. But here only the which one? Tension 9 kg weight, then the tension. Okay, tension you have to find out. For the frequency 900. Frequency and tension relation, nu is directly proportional to square root of tension. Okay, initial it is given, fundamental frequency it is given 450. 450 it is directly proportional to tension given 9 kg weight. 9 kg weight, this one. And for the second case, frequency is given 900. We have to find out tension. We consider unknown T dash. By dividing these two equations, we can get 900 divided by 450. It is equal to square root of T dash divided by 9. The right hand side square root is there. Now squaring on both sides, we can get here 0 get cancelled. You can cancel it. 49 1s are 49 2s are. Squaring 2 square is 4. T dash divided by a square root get cancelled. 9 or T dash equal to 4 into 9. 4 into 9, that is 36 kg weight. Now for this problem, correct option is 36 kg weight. Okay, move to the next problem. 29th problem, it is given your wave of frequency. Frequency is given 400 Hz. Velocity is given 320 meter per second. The distance between the particle differing in phase by phase in terms of angle, it is given 90 degree. Okay, you have to find out distance. Here, distance between the two particles. That means you have to find out the path difference between the two particles. Okay, for one full wave path traveled by one full wave is lambda. Now phase changes from this point to this one, that is 2 pi. Now relation between path difference and phase difference, we knew that path difference, it is equal to lambda divided by 2 pi into phase difference. Okay. Lambda divided by 2 pi into phase difference. Now lambda wavelength direct, it is not given here. Frequency and velocity is given. Now frequency and velocity of sound relation V equal to nu into lambda, or lambda you can get V divided by nu. V is given 320, frequency is given how much? 400. 0 get cancelled, that is 32 by 40. You substitute lambda place 32 divided by 40, lambda place into what is there, 2 pi is there. Then phase difference. Phase difference in terms, it is given 90 degree. 90 degree in terms of radian, pi by 2. It is pi by 2. Pi get cancelled. Okay. Here 2 ones are 2, 16s are 2 ones are 2, 8. That is 8 by 40, 8 ones are 8 fives are 1 by 5. 1 by 5 meter, correct? No, your option it is given in centimeter. 1 by 5 is 0.2 meter. Now 0.2 meter, 0.2 meters. 0.2 is not there because option is given in terms of centimeter. You have to convert meter into centimeter. 1 meter equal to 100 centimeter. 0.2 divide into 100, that is 20 centimeter. Now for this problem, correct option is 20 centimeter. Okay, move to the last problem, 30th problem. A transverse wave passes through a string with the equation is given y equal to 10 sin pi 0.02x minus 2t, where x is in meter and t is in seconds. The maximum velocity of the particle in wave motion is maximum. Direct, we knew that maximum, V maximum equal to omega into A. Now here also you have to remember the standard transverse wave equation, that is the standard form of progressive wave equation, y equal to A sin, that is kx minus omega t. Now here pi is outside the bracket, you can write in the form y equal to 10 sin pi, this one pi taken inside the bracket, sine of 0.02 pi x minus 2, that is 2.00 is 2 pi t. Next comparing k place, k equal to, comparing the given equation with the standard equation, we can get k place 0.02 pi, or k in terms of which one? Oh sorry, here you to knew that omega place, comparing these two equation, omega place 2 pi direct, or A place, A is required, no, A place is 10, that you can write V maximum equal to 2 pi into A is 10, 2 into 10, 20 pi. V maximum is 20 pi, option A is given in terms of numerical number. Now pi value, already you knew that, pi is 22 by 7, 22 by 7 is 3.14, 3.14 multiplying by 20, we can get 2 how many times, 2 to multiply this one, 2, 4, 8, 2, 2 3s are 6, 6 correct now? Okay. 20, that is we can get 62.38, 62.84 is option is out there. Okay, round up. This one is nearly equal to 63. Correct option is 63. Understood now? Okay. All the 30 problems I solved. Okay. ಎಲ್ಲ 30 ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿದ್ದೇನೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಒನ್ ಆ್ಯಂಡ್ ಆಲ್.